Hi, so what we're going to do in this video is look at the scalar triple product. Okay? So we've used the cross product or the vector product before, and then higher we learned about the scalar product or the dot product. So this is a combination of the two of them. So for three vectors, a, b, c, the scalar triple product is defined as a dot bracket b cross c, and that equals the determinant of the matrix that I've set up there. So as long as you remember to calculate determinants, which you'll know from matrices and also from calculating the cross product, you should be able to calculate the scalar triple product. Okay? So the first thing to realise is that instead of I, j, k in the top of the matrix, we've got a1, a2 and a3, which means they are going to be scalar quantities, which means that instead of getting a vector, I'm going to get a scalar quantity when I calculate this. So I should end up with a number at the end. The scalar quantity as a byproduct is also the volume of the parallelepiped. I had to Google it to pronounce that. It's the volume of that shape, which is just essentially a 3D parallelogram. Now, if we end up with a positive or a negative value in terms of the volume, that just means it's to do with the direction of the vectors and where they've been pointing. So I might end up with a negative value here. But in terms of if you were asked to calculate the volume of the parallelepiped between those three vectors in example 1, it's just we could end up with negative, but that's more to do with the direction of the vectors as opposed to having a negative volume. So the first thing I'm going to do is set up the matrix, calculate the determinant, and then be able, and that will give me the scalar triple product. Okay? I'm going to try and work on the sound quality, so I'm not going to speak while I'm at the board. So I'll just calculate the scalar triple product and then come back. So there, what I've done is I've calculated the scalar triple product. So first of all, split up the determinant into the individual determinant components, and then individually calculate them, making sure that I have been careful with my negatives, and then worked it out in the end. So that is a scalar triple product of those three vectors, although if it was a question saying what is the volume of the parallelepiped, then it would just be 12 units cubed. In this case, I've not actually asked you to do that. So that is the scalar triple product.